Hello, my name is Christopher Buck. I am a student in the summer 2013 LARS program. My mentor is Richard Pappa of the Structural Dynamics branch, and today I will be showing you the modeling application I have programmed this summer. This application was written in Wolfram Workbench 2.0 for use with Mathematica 9.0 and serves the purpose of making interactive simulations versatile and easy to create. So let's begin by looking at the geometric objects included in this application. First, I'll import the application, just as I would normally, and then we can look at the box. The box is the most basic of the geometric objects, and includes an X, Y, and Z length. However, this is only a stationary box. If we want to rotate it, we can do so with 3 rotations, by default in the order of X, Y, and Z. After this, we have the option of offsetting the box. In order to show how this is offset, I've included a sphere. The offsets are in the order of delta x, delta y, and delta z. Next, we have the ability to set which indice is being used for the offset. Normally, you use indice 1. However, you can change it to use any of the indices. In this example, I've set it to use indice 3. You can get a list of the indices by typing in PTS and can pick a specific indice or X, Y, or Z value. It's just shown here. This is the X value. Last, we have the ability to set the order of the rotations. This is normally X, Y, and Z. However, because we set it as Y, Z, X, this is a Y rotation, a Z rotation, and an X rotation. Next, we're going to look at reflections. Reflections normally require a vector and a point. However, this can be difficult to predict with my application, so I've made a function instead that will work. The first parameter of it is an x, y, or z string, or a negative x, negative y, or negative z string. Then we have the set of points from a base object, which I will explain in a moment. A string that is either one or several objects. So if it's several objects, I'll list them as so in the same string. A distance variable, which is the distance between the base object and the reflection plane. And 3 rotations that correspond with the base object's rotations. Base object is needed so that subsequent reflections can be made. If you wanted to take, say, this reflection after it is finished and make another reflection of that, you would still need a base object to work off of. Without the base object, you don't have a set of actual points to work with. However, this does not mean that the base object and the original object can't be the same. I'm going to show here that they can, but do note that the base object has to be a box for this program to work, or of type box, so a box, a tube, or a box with a hole. Oops. Now the orange object is not only the original object, but it is also the base object. Rotations on the orange object also affect the red reflection in all 3 directions. However, sometimes you will not enter all 3 rotation values. Sometimes you will want parts to hinge, as shown here. To do so, simply put a 0 for the parameter of rotation that you want to ignore. In this case, I've used y. Because it is the distance and the reflection plane ignore this rotation, this reflection plane stays vertical while these parts hinge. However, the other two still affect it. I've also given an extra parameter, a string that says bottom. This is because both objects hinge towards the bottom. However, this can be changed to hinge towards the top, or in these cases towards what I refer to as south and north, as well as east and west. The last thing I'm going to show is an options constructor, which constructs an options toolbar with sub-options under main options that you can edit. This is made with two lists, a variable name, and any extra manipulate options you may want to add on. The first parameter, the variable name, is the variable that switches between the different sets of options. It shouldn't matter what name you use, but if you prefer one, you can enter it, and it will work all the same. The next parameter is the list of titles, so the list of main sets of options. Then there is a list of sub-option settings. Each set of sub-options is its own list, and in it are lists of the following: the variable name, the lower bound, upper bound, default value, and name according to how it will be displayed here. While made to work with number values, you can make a checkbox from these as well. Which can switch between a true and false value. This can also be combined with this setup shown here for the modeling. This is explained more in depth in the tutorial that comes with this application, which gives you a full walkthrough of how to make your own 3D model. But for a more interesting model, I'll pull up this one. This model is a government reference array of solar panels, which has a full deployment sequence, as shown here. And can also have any of these values changed for any part of it. So for instance, if I decided that I need to make the solar blankets shorter, I can. Or perhaps the funnel over here longer, I can. Wider. Maybe a bigger radius rocket. A taller or shorter one, or just to make it disappear for now. All of these are variable and can be changed, any fitting, and the model will still, for the most part, function even after these variables are changed. that is the end of this video on my application, and I hope you've enjoyed it.